So I will start right now with that webinar, and first I have to thank Sarah for the wonderful introduction, and of course for the organization, and of course the KNX Association for the possibility of doing this here. Our main focus today is KNX IP secure routing. Of course, the secure functionality of the new devices which will come this year and which are already on the market. So some basics from the setup to the filters, but also some information about secure. And I tried not to stop items coming with a secure or unsecure routing. So where's my next slide here? Oh, sorry. So the agenda is here. Just I will introduce the example device from Enertex. So this is already in the market now. I think it was one of the first devices, and I will explain just the basics on that. And then we go on to Unicast, broadcast, and multicast as an example for communication, which is very, very important for routing, as well as the topology setup, and that is also in that very sophisticated theme for ETS setup and the topology errors which might occur if you don't do it in the proper way. Then I will tell you about something about filtering, and finally we're going up to security, and I will just explain fundamentals for security and for routing and tunneling, and of course the complete key handling. So we just go over the first point is the example device which we are talking about, or I'm talking about, is KNX secure router from Enertex, which you have seen here on that picture. From the first side you can see there is an OLED display on it, so we will have some basic information about the device and its actual state. It's a complete bus-powered device, as a lot of new devices are, and it's providing both secure tunneling and routing. What is very unique is, of course, the very high telegram rate, so it's really possible to send about 50 telegrams per second, which is about 100% bus load. And of course, it is UDP and TCP communication enabled. TCP communication is mandatory for every new KNX secure routing interface or router, tunneling or router. So this is a benefit for every new device, even if you use it for just plain mode. This device has the possibility of 8 tunneling connections and has 62 group address filters. I will demonstrate later on. We have APDU, which is the bus load for TP telegrams with up to 248, and we can parameterize it. So it's a lot of flexibility here and a lot of really good performance. Yeah, we have the telegram rate limit possibility. So this means that if we have perhaps an infrastructure which is not possible or which has problems with a high telegram rate, we can buffer it in the device and make it more smooth over the time. So it has a high telegram buffer in it. And of course, at least, last but not least, a telnet interface. I will just give a short impression at the end of this. So let us start with some theory. Well, you can see here on the left side here a unicast communication, which means it's just a communication from one sender to one receiver. So we have 2 participants, and the possibility, if you do it unicast, is you can do it connectionless or connection orientated. What means in detail, for example, connection orientated is you send a message to a receiver and he gives back you a feedback like, I got this message now, it's ready, I got it. And so you have a kind of how to say, I think you could be sure that you have sent your telegram and it's really at the receiver on its way. So this is the advantage of connection orientated unicast communication, which we will find later on. Then there is the possibility of a broadcast, which means you have one sender and a lot of receivers, actually not a lot of, all receivers in the network will hear you. So this is guaranteed. If you do a broadcast in your network, everyone will hear it. So this is that point. So this is actually a one-to-all communication. And for the last one, we have a multicast, which means one point to a lot of receivers. So of course there is a group of receivers, and you have to define the group which will be to your communication part. So it's required that these multicast addresses are known to the separate receivers, and that the groups are defined. So this is just the basic theory of communication. And if you go to the KNX TP bus, which we also have on each KNX IP router, of course, on the KNX TP side, we have now a lot of devices which are programmed with individual addresses in the form of 0 to 15, 0.0 to 15, 0.0 to 255. So that means now each device knows its address. And if you know, and I expect you to know something about group address and of course basic communications, then we have to say that a unicast connection, for example, is a programming of a device. So if the ETS downloads, for example, to an actor or to a sensor a certain program or its program, then it's a unicast communication, because it's one point, ETS, to the other point, which is your device, and only these two are in that communication. Normally this is also a connection-orientated communication. If you look at the bus monitor of the ETS, you will have, for example, or you might observe the T-connect, which is just open the connection, and then there comes the sequence with the single telegrams. So this is programming of the device application as a unicast. In the broadcast, we have normally just like if you want to program the individual address of the device, you put on your program button, and then it will be a red light on it, and you will see that there is a possibility of downloading to one single device. Every device will hear this broadcast, but only that device which is in the programming mode will answer. But in general, this is a broadcast, everyone will hear you. And then there is, of course, the multicast connection, which is very common, known as the group address communication. So where you have, for example, one sensor communicating to 3 actors, and these 3 actors will, of course, as long as if they are programmed on the group address, will hear you. So what we can see is the KNX TP, we have unicast, multicast, broadcast, and this is by design. So just depending on your addresses which you are downloading, everything is clear. And normally if you do so, and you are expert in KNX TP, you won't think a lot of these problems, because there is no problem. It's just by design in the ETS already. So there is normally not an additional setup tool or something. It's just because of you know what a group address is, and you know what an individual address is, and that's it, and that's how it works. Yeah, and that's differently if we're going now to IP communication, which is the second part of our device for routing. If we consider only TCP, for example, then it's very well known that TCP is actually only a point-to-point connection, so it's only a unicast. And therefore, in the past, it was clear that the devices only supported UDP, because UDP also can be made as a unicast communication, so a point-to-point communication. But UDP also allows broadcasting and multicasting. And multicast is now differently in the LAN communication than it is in the TP communication. In the LAN, where you normally only have a point-to-point, so every single receiver has its own internet address or its own LAN address. So there is normally not like I think like a multicast. So what we have done here, or what we have to do, is here an IGMP software stack, and this is a requirement for KNX IP routing, that you have an IGMP possible device in your LAN, which allows you just to communicate with these address range. If you're looking at IP version 4, from 22.4 from 22.224 to 239. So in this address range, it's more like you can perhaps imagine like a box where you put in your message, and all the others which are configured for that address also will hear your address. But it's made in software. And at the beginning of KNX routing, at least I experienced a lot of problems with, for example, the Fritzbox, which the German audience will perhaps know. They had problems with that IGMP. And still there are some LAN devices having these problems with IGMP. So, but it has to be known that IGMP is in any time it's UDP communication and not TCP communication. So we will see later on what this will be, what this means. So first, it's of course very important if you do a routing in your network, a KNX IP routing over your normal infrastructure. It must be possible to do multicast. So this IGMP software stack must be possible with your LAN router. And then of course the multicast IP address must be defined. So the normal multicast address you will know from KNX here is just a standard multicast, but of course you can, at least theoretical, choose different ones and make groups of multicast islands, for example, if you have a lot of different infrastructure in a bigger project. So what normally you would do with a routing is you send a telegram from one line to another line. So what you have to do is sending this telegram over the first router to the backbone. And the backbone now is your LAN device. The green shall be your TP line. So on that backbone you send the information, and then the proper device at this, for example, at this router here, if you want to go to 3, has to recognize that this telegram should be routed to its line. And normally you don't want to route a telegram to, for example, line 2 if it's not for its line, or you don't need to send a telegram over the backbone to another line if it isn't for that other line, if it isn't important for that other line. So for the structuring in the TP world, we need this topology in the KNX system. I would go one step further, and I just explain it by the picture here. We have the area coupler functionality. That means if you give your device 2 zeros at the last the physical address of the routing device with 2 zeros, then its function is an area coupler. An area coupler only can couple areas. So that means all his sublines has to start with a 2.0, for example, here, and he only can couple telegrams from that line up to the upper line. So only the first number here is important for its coupling function. Whereas if you're doing as a line coupler, for example, then it's important that this device has a 0 at the end, but not in the middle. And if, for example, something like this occurs, where you have two area couplers and one line coupler, this will be an invalid topology. And it could be that your system runs for some days, for some months, but there could be a situation where your complete system failed, and therefore it's really needed and very important that you check your topology in your KNX system. And for the topology, not only we have, okay, for the first thing is of course doing it for the TP side. So either as a line coupler or I'll go back just a moment, as an area coupler. Again, you can couple all areas from 1.00 to 1500, or as a line coupler, starting from one to another, like this here, from 1.y to 0 to 1.y0. But this means, of course, it must not be the same. It could be better like this here. And we have the possibility of word coupler. It's a very special thing I don't want to discuss here, but in general in our devices this is possible, but not for any KNX IP secure router. It is possible. It's depending from device to device. Yeah, so if you want to set up a new project, normally you just make a new project, and you of course have to check that the medium on the backbone is IP and your lines will be TP, and then you will have, for example, like this. And that's the first problem I really faced at the beginning here with the topology. As I told you, you have to put in your multicast address. The multicast address is the address where all these IP routers now communicate on the LAN side. And in order to come to that setting, which you see here, you have to really press on that topology bar at the top. So if you don't know that, you won't be very easily able to set this multicast address, because the multicast address itself, in the former times, it was in the devices properties, but now as the KNX has started to synchronize, every KNX IP router should have the same settings or the same dialogues. So they started to put it in that dialog, and you can find it over here. What you see here is, of course, there is it shows you that this backbone will be secured. You have a network latency. What does it mean? Well, we will see later on that each telegram has to have a timestamp in order to avoid replay attacks. So, for example, if you have a security functionality and you and you have encrypted your telegram, you must not only be sure that its telegram is really good encrypted and no one can really read it, but it's also very needed that this telegram cannot be replayed. So if one really observes you and sees, okay, if you, for example, send that bytes on the bus, then this light will go on. Never you have the possibility to decrypt this this telegram. Anyway, you have to see that it is possible, if you just replay it, that you could switch on the light. So therefore, every encrypted telegram has not only encryption but also a timestamp in it. And for example, if you have a setup with a very high latency, you can change it here in the ETS. But this is the same for any KNX IP secure router. So if you put now a new device in your project, the first thing you are asked is to set a project password. This is the project password for the ETS project. So if you just leave it and you don't want it, then automatically your complete secure devices will be set as unsecure devices. So the first thing is you need a secure password for your project, and then the second thing, once you drop in a new device as our secure device, then you are asked for a key. Normally you can just enter it by hand, but this is a really hard job. Another thing is you can press here and scan into your FDSK, which is actually something like that over here. But I recommend you do it once you start with the real programming. So in the beginning, you just can skip it and say later on, and I will show you later on why this makes more sense in my opinion, but it's only my personal recommendation. So once you have added the devices into your project, let us say here, for example, 3 lines, you can see on the first your line has now 3 routers. Here in our case, of course, the Enertex routers. There is one address C here is 1.1.0. So this, as I told you, is the line coupler functionality. And we see the 9 in the up, and this over here, and this 9 just means we are having 9 physical addresses in that device. So one is for the device itself. So what you see is 1.1.0, but there are 8 more physical addresses for the tunneling addresses, which our router has. And you can see here also a blue shield, which shall show you that this device will be secured. But contradictory to that symbol, a secure device needs an X symbol on its label. So actually means this shield symbol is kind of meaningless, I think, at least on the package. On the package, you really have to look for the X. It's just an X symbol, and if you buy a new device, it should be an X on it in order to see that it's a real secure device. But in the ETS, you see this blue shield. And then again, if you do the basic setup, so like the ones you do it in the past, for example, for IP settings, now you have contradictory to former projects. Now every normal secure router has this standard dialog. So a standard dialog means you don't have, it does not vary it, but in our device we have just made some hint into that dialogs that you can find it more easily, that you see you have to click on that tab and open the properties. And of course you can see the multicast address, but you cannot edit it. If you want to edit the multicast address, as I shown you before, you have to just click on the topology. We have a commissioning password. This is the password you need if you want to change the settings of the device. You can use it as it shows, as it is generated by the ETS. But you have to know this commissioning password if once you want to, for example, open a bus monitor on it in another project. So my recommendation is perhaps for very often used projects, do your own password and make it so that you can easily remember, but it's also secure. Authentication code is not necessarily needed for communication with the device. It's an additional parameter for more secureness, for more security, but actually not obligatory for communication with the router. So now, as we have seen the basic setup, just some. I go over the routing and the filtering. On the one hand, we have, of course, filtering for individual addressed telegrams. That means each router, of course, knows its line. So its line means this router, as it is programmed to 1.1.0, will know that any other device, starting with 1.1 point, will be in its line. So if there is a telegram coming from over here, he will immediately know if it's for its line or not. And the same is here. So actually there is not a need of filter tables or something for download. It's just you parameterize if you want to use that filtering from the individual address telegrams for that device. So as it is here in our Enertex device, it's like that, and it might be very, very similar in all the other devices. You just can, for example, say here, I want to filter telegrams coming from IP to KNX and vice versa. That means only the telegrams which are for the line, or for the TP line for that device will really come through that device. Others are blocked. And the same, you can just block broadcast telegrams. So, for example, physical address read. If you want to see if there's a device in the programming mode, normally you can just block this telegrams. We have in our device an additional feature. Normally, for example, if you have a standard topology like that is in a normal house where you have an in-house line and an outside line. And there could be a possible attack in conventional routing situations, that if you normally block the individual address in that router, that would mean that if you try to program it, this line over that line here to that, I'm sorry, this would be, yeah, that's right. So for example, I want to reprogram this device 1.1.2. That would be very easily, if I didn't, if I block the filtering here, that would be not possible. But there could be an attack scenario where I really go on that line and reprogram the router if it's not secured. And for that, in our devices, we have for the plain mode the possibility to inhibit programming from KNX side. So this is just an additional feature which is here very comfortable. Another thing is normally if your topology is incorrect, a lot of problems can occur. I don't want to be into more details, but for example, if you have here on that line an additional device started with 0 with a line 1, which actually should be 2, then there's a violation. And in our router, if you just say check topology on, then normally, or the first, you see this root network parameter response message in the bus monitor, which might be not that very clear. So in our display, there you can see something like that, subline topology violated by that device. So this is just for additional benefit of that devices from Enertex. And then there is, of course, some group address filters from the past. You see, normally we had these groups 0 to 13 for their group addresses, and 14, 15 might be very common or very well known. The new secure routers now must also support group addresses up to 31. And what we have done here in our devices, we just left it at these blocks. But of course, it could be a scenario where you want to be more differently like that. And therefore, you can have the choice that you can change any group. For example, group 6 from that normally filtered. Normally, it's perhaps blocked. Then you can route it. So you have high flexibility of filtering from group addresses. And that means for each direction. So altogether, we have this 62 group address filters. So just have a short impression that you can see how this is done in the application. We have just route, block, filter, or disabled. That means once it is disabled, then there is the complete group filter active, or you can just really put a single filter on each group. So I think, yeah, data secure. So we now start the security, or I just want to explain a bit. Security normally just means you have these telegrams, which you now, if you go on a plain subnet and you just take USB and you see just the telegrams, and from the telegrams, if you know, are expert in KNX, you can very easily see where this telegrams comes from, where should it go, what does it, or which data does it communicate. So in general, security means just you put algorithm on that data stream and make a new data stream out of it, and the real art of encryption is that this new data stream does not contain any pattern, which it might contain if it would be unsecure. So, for example, if you have a pattern in your four zeros in your original data, then there would be not 4, let us say, AA in the encrypted software. So that is very important. And for now, it is AES 128, which really has this property. and therefore now all telegrams are insecure, encrypted with this AES 128. So data secure now means that we have on our TP line the possibility that some of the telegrams are encrypted and some of them are not encrypted. So we can have both together. But a group address, for example, if you communicate with a group address, then it's either encrypted or not encrypted. So either plain or encrypted. Encryption in data secure only affects application layer. That means the telegram data is hidden, but you can still see in data secure the receiver and the sender. That of course means that if you have an old IP router or whatever coupler, then it's no problem for an old router to really route the secure the data secure telegrams over its backbone, because it has the information from the transport layer, so it knows to which receiver or sender it will have to send it, and therefore you can of course use your old couplers with a data secure devices in the TP line. IP secure now means that on the IP side everything is encrypted. So once you have, for example, a backbone, then any telegram on the backbone will be encrypted. So there is not a possibility, as it is, for example, in the data secure on the TP line, where you have a mixture possible. On the IP backbone, either there is secure communication or there is not. And the same is from the backbone or for example, for tunneling. And if you have already a KNX data secure telegram, for example, on your TP line, you have already a secure telegram, and this will come up to here where we have a secure router. Then this telegram will be again encrypted. So the encrypted telegram will be encrypted again, will be decrypted, so that the decrypted telegram is still the encryption of data secure in it. But the big advantage now is that here on the IP backbone, even the transport layer is encrypted. That means any information from sender and receiver now is completely secure. No possibility of seeing from where to what something is going. Yeah, as I told you, the backbone is encrypted, and what we here have is the multicast. That means that our routers must communicate with UDP, as is in the beginning of that presentation, where I told you that on the LAN telegrams we need multicasts, which means that only UDP communication is possible. Yeah, we have routing with UDP only, and that means if we want to have multicast in routing, then we need UDP. And that of course also means our IP coupler have all the same backbone key for the communication. And this backbone key normally you cannot change. This is done by the ETS and the project, and you won't see it directly. So there's no need for you to change anything. You just click on secure communication, and that's all. And then, as I told you also, these routers have now not only to encrypt the telegrams, but they also have to provide something like a timing algorithm, so that they can distinguish telegrams which have been already sent and in the past and should not be determined again. So therefore there is a timer in it, and of course there is still the one dangerous scenario when you start up your complete installation. Then you need a time master at that very beginning. And with our devices, we used a buffered real-time clock in it, so that this scenario is very good optimized, because these RTC are buffered and these devices don't lose the synchronization over several hours and days. So it's very well protected against replay attacks. Tunneling is a bit differently. It's only a one-to-one point connection, and that means in that case it could be a TCP connection, and as it is standardized by the KNX, tunneling, encrypted tunneling or secure tunneling is always TCP communication. TCP communication has an advantage even in plane mode, that you don't have to handle these connection telegrams, which you have perhaps seen with a sequence number. I've heard about that, because in the UDP communication there's only connectionless, and they have to make an additional layer on it. But with going with a TCP communication for tunneling, it's much more easier to do it, because TCP already has this Unicast communication in both directions. So for tunneling also, now the standard sees that there's a session key, which is actually a key only valid for one new session generated for each new tunneling connection on runtime. And so we have one time we are at the beginning, we will be authorized with another device with a tunneling password. We have to give a tunneling password for each tunnel. It will be used only once, and then they will generate a new password out of a randomizer, and with that it will be communicated as long as this session is valid. That means even more security. So as you want to have the real big security of the ETS now, if you program it, it normally will do a tunneling connection, because the tunneling connection is the most secure connection that KNX provides. And as I told you, it's also here a standardized dialog. So it's a manufacturer independent dialog again, where you just put in a tunneling password here, and you have to remind of it, of course. I think we have it in 5 minutes, so Sarah, I hope you don't mind. I will need some more time. Just to make it short, we have keys and passwords, and you might have heard of, and I already used FDSK, which is factory default setup key. So this key will be done by the manufacturer, by the manufacturing process into that device. So if a new device will be programmed, this key is in the device, and if you want to program the device secure, you have to know this key. So actually this key will be used only once by commissioning. It will just encrypt the commissioning password and download into the device. But for that single process, again, there is this FDSK was necessary. After that, we are programming the device with a commissioning password, which then is into that device and now possible to change by the user or by the ETS. And for the tunnelings, we have again different passwords to give. So we have these 3 keys, just to give you an overview of this. And as I told you before, normally you have, for example, to put in such a key into that device, if you really put it into your new project, and it might be take too long to really write it into. It's very easy to do it. Normally if you get your new device, you will have a paper where it's printed on it, and you just collect. My recommendation is collect all your sheets, and once you are ready with the basics, you just can take this sheet and hold it before your camera in your laptop or webcam, wherever you have, and then it can very easily read out the key. And this does not take very long. So it's a very, very efficient way to put in this FDSK. A bulk scan is then very fast. Yeah, and just give you some overview about our Enertex devices. Again, is we have the possibility as using the Telnet client in plain mode only, just for security reasons. But in plain mode, it's very comfortable to change, for example, TCP/IP settings very directly, setting the tunneling addresses, diagnostics. We have also a function we call block filter, where you just block all the complete filtering in the device, just in order if you're looking for some errors, why is there a telegram not already routed, or is it blocked by because of the filtering or something. So it's very easy to take to just stop. And of course we have the possibility of not of course, we also have the possibility of changing the length of the APDU. So this means the programming of a device takes longer the shorter your telegrams are, of course, because of the payload of your telegram, and we can change it. I will come to the end in 2 minutes. So I just show you what you can see here on that slide, is that we have a lot of additional information which you can only see if you use the Telnet interface. And what we also have is direct device information, like showing on that OLED we can see firmware version, IP address, physical address, serial number, bus voltage, used tunnel connections, IP settings, and a lot of more things, which gives you a very easy commissioning. And this is like, it looks like today. Actually it is like this, and I hope you have a nice afternoon, and now I'm ready for your questions.
Okay, very good. Thank you very much, Michael, for the great presentation. So now we are at the Q&A time. I already see that a few questions have been raised. Michael, can you see them?
I'll have to look.
Okay, so
okay, I see. Can I ask, does it support SSR access only unsecured Telnet? Yeah, it is so that SSR is not possible if it is, or I'm not, no, I have to say Telnet is not possible if it's in secure mode. You can, of course, you can do it by hand. You can very easily switch off this function or the secure function. For example, if you are experimental, you do experimental things, but I would not recommend. We actually do not have an SSR implementation in the device. So Telnet is only possible in plain mode or in secure mode if you enable it, but then it's of course a security risk. So I go to the next question. Is it possible to have a secure tunneling connection and additional another tunneling connection with this unsecure mixed in the same router? Yes and no. This means if your router is not yet secured, and you make you open an unsecure tunnel connection, then this unsecure tunneling connection stays open till the device is secured. But even if it's secured, it will be open not before it is restarted. But as I see in the ETS, so this is just the standard which says so. But if you program it with the ETS will always reprogram and restart the device. So actually, in practical things, I have to say no, it's not possible. But just because of the ETS, not because of the device. And there's the next question. Is it possible to work for the ETS 571 for data and IP secure? I would say it should be, but there could be some problems. Is the X marking? Yeah, is the X marking going to be the marker for all KNX secure device? Yeah, actually, it is obligatory that you have the X mark on the KNX secure device. But I have seen, and I know because we are also selling OEM devices now, that this here you can see that X symbol. A lot of the customers now also try to put that blue shielded on it. because they think it's more convenient or more, as you see it in the ETS. But this, they could also make a picture of Mona Lisa on it. It doesn't mean anything. It is standardized that there has to be the X on the device. So for you, it's only really the only thing you have to look for is there X on the device, and there should be the X for TP means data secure, and the X and in the upper the IP means IP secure. So a normal secure IP secure router should have this X on it.